diode. Now you can see I'm going to go for the construction of pin, but having understood what is a pin photodiode, now I am going to fabricate pin and FET in the same substrate. So I'm going to fabricate construction of PINFET. I'm going to fabricate the PINFET on a single device. So we are going to fabricate a PINFET, which is going to be an optical receiver on a semi-insulating. I'm going to use an indium gallium arsenide substrate, and I'm going to grow this layers by using what is the process. It is called as MOCVD, metal organic chemical vapor deposition. So I'm going to use this technique to grow the different layers of your PINFET. So the structures you can either go for vertical or horizontal integration. For horizontal integration, the pin photodiode is inside the substrate and FET is on the adjacent portion. Horizontal na, it is just like you connect the two components in cascade. Vertical na, it is going to be parallel. That is what is given. You see here for horizontal integration, the photodiode is fabricated on the substrate and the FET layer is present adjacent. So FET to photodiode, it will be very near to each other. That is going to be horizontal integration. For vertical integration, it is sequentially grown. So first I am going to grow the photodiode. Above the photodiode, I am going to fabricate the FET. And both the photodiode and FET are separated by a very high resistivity isolation layer. So either you can go for horizontal integration or I can go for vertical integration. So here we are going to see a horizontal integrated structure of pin and FET. So substrate mala, I'm going to grow the pin photodiode. Adjacent to pin photodiode, I'm going to grow the FET. Okay, so by growing this horizontal integrated structure, the response time is going to be varied from 1 nanosecond to 40 nanosecond. Okay, I can vary the response time from 1 nanosecond to 40 nanosecond by growing this horizontally integrated structure. So PINFET is an integration of gallium arsenide pin photodiode and an indium gallium arsenide FET. So you can see here nowhere we are using silicon or germanium. What is the reason for not using silicon or germanium when I am fabricating PINFET? Can anybody say the reason for not using silicon or germanium? I have told this reason
They do
long.
not produce light.
Very good. Silicon and germanium, they don't produce light. What is the reason why they don't produce light? There is one important point why they don't produce light.
Direct band gap. Indirect
They
band gap.
have they have direct or
Indirect.
indirect. Yes, all these silicon and germanium have indirect band gap device, indirect band gap. But I told you group 3 and group 5 elements, gallium, indium, arsenic, phosphide, all these have direct band gaps. Only elements having direct band gap are eligible for producing light. So that is the reason, since I'm going to deal with an optical receiver, right? So when I want to deal with optical receiver, I want to deal with fabricate the structure of PINFET using elements which are having optical properties, or I can say which are having direct band gap. That is why I choose indium gallium arsenide here. This one, the indium gallium arsenide is a mixture of three compounds: indium, gallium, arsenic. There is one more type of element which is a mixture of four things: indium, gallium, arsenide, phosphide. They call it as INGAASP. Phosphorus will also come into picture. So that is the tertiary compound. Tertiary na 4 element இருக்கும். Here it is a trinary compound. Trinary na 3 இருக்கு. Binary na 2 இருக்கும். Primary na only one. Silicon or germanium only if you use it is primary. Binary means I'll be using gallium arsenide. Combination of any two. Tertiary. Sorry, tertiary means it is going to be, I'm going to use combination of two. Indium, gallium, arsenide, phosphide. Trinary na 3. What you have seen here, indium, gallium, arsenide. So any you can go for either binary or trinary or tertiary. Any three types of elements you can use, you can go for this construction of PINFET. So there is no specific reason why I am choosing indium gallium arsenide, just because it has to work with light, and indium gallium arsenide is going to have a direct band gap. I have chosen indium gallium arsenide. Otherwise, you can very well go with gallium arsenide, or you can go with indium gallium arsenide phosphide also. You can go with those two things also. So the construction wise, you see, I'm going to take an N plus indium phosphide substrate. Over that, I'm going to go an N type gallium arsenide. Okay, and above that, I'll be going P type for pin diode. And I told you pin and FET will be adjacent to each other. So above that N type, I'm going to go for substrate as indium phosphate for FET. N, it will have N channel, and I will be doping two N plus regions and one P region, and N plus regions will be the source and drain, and P region will be your gate. You know, these two are horizontally integrated, because you can see the substrate is going to be same, but pin diode pakatla you can see the structure of JFET coming. Diagram wise also, you see whatever the pin diode and FET will be connected in cascade. So whatever is the output of pin diode will be going to cascade of their FET, because both the devices are in cascade or series connection. Okay, so the PINFET is made with a high sensitivity. The diagram you can see, it is a indium phosphide FET. So uh, over the N type indium gallium arsenide, I'll be growing P type indium phosphide. Okay, that is going to serve as the PIN diode. It is going to have three layers. So first, the material is going on N plus indium arsenide. So the indium gallium arsenide layer, consisting of low electron concentration, is grown by different layer technique called as vapor phase epitaxy. And then only you are going to subject this to MOCVD, chemical molecular organic chemical vapor deposition technology. So other layers are grown as per what is shown here. So you are growing everything on a single substrate, and you can see this two layers are adjacent. So they are going to be called as horizontally integrated structure for PINFET. Okay, so any doubt so far in your construction of PINFET?